not to worry. Figured out my mistake. Happens to the best of us and the worst of us. So, made a little mistake here. Plus 3 would actually turn that into x squared minus x minus 6. Thereby giving us a quadratic x and x, 3 and 2 minus plus. So we're still going to get two values for x, positive 3 and negative 2, and we're going to have to find the corresponding y coordinates. So go ahead and erase that one out of there. Put something a little nicer there. 3 are going to get 0, right? 3 minus 3. Check it there as well. 3 squared minus 9. If I plug in negative 2, I'm going to get negative 5. So I've got 3, 0, I've got negative 2, negative 5. That shows me the two places where these two functions cross. So there's my linear piece. Don't laugh, it's a line. And the quadratic piece, remember, x squared minus 9 is just a parabola shifted down 9 units. Check this out. We know it's going to do this sort of thing. So there's our two solutions. Now you ask, couldn't I just done that on the calculator? Well, sure. We're going to graph the two functions. We're going to find their intersections. We can use either the table or the graph feature to do that. All right. Back in the swing of things. Let's give ourselves a clean slate. Okay. All clean. Number 7. So, we have 3 equations to solve. They're all dealing with absolute value. Seems like forever ago, right? It was last year, technically. Right, but if we look at the first one, the biggest part to remember about absolute value is thinking about the two possibilities. Absolute value is the distance from 0. So it means these values can be either the positive or the negative side from 0. First rule of thumb, isolate the absolute value. So we're going to have to move this 2 and this 5. We're going to subtract the 5, make that negative 1, and we're going to divide by 2. Divide by 2. So what I have here is x plus 1 equals negative a half. Are you thinking what I'm thinking? Absolute value equals negative 1 half. How can the absolute value, the distance, be negative? Can't. Good news, there is no solution to this one, right? So that's kind of, I wanted to make sure I put one of those in there so that we remember we got an easy way out if the absolute value is set equal to a negative. Alright, so on to part B. It's going to have some of the same steps. Ooh, this black is really nice. So we've got to deal with that minus 2 first. That's got to be moved over to the right. So I'm going to move it up. So plus 2, that's really going to be 10. So what I'm looking at now is that 2x minus 3 is 10 units from 0. 10 over here on the right or 10 on the left. So how do we deal with that? We set up two equations. 2x minus 3 equals 10. Or 2x minus 3 can equal negative 10. Hope the shaking's not too crazy. Two-step equations are easy to solve. We're going to add the 3 and then divide by 2. So x is going to equal 13 halves. Or, same steps, different outcome, divide by 2. So x is going to equal negative 7 halves. And I have both answers there. So it's kind of like a parabola. It's got those two answers. Remember, the graph of an absolute value is a V. It's two linear pieces that come together at a vertex. So, moving on from there, thinking about that graph, there's two places that could have the same y value. So that output's kind of like the y value, right? Just say yes. I can hear you. Okay. Not really. That would be creepy. So, x plus 2 inside, and here we're changing over to an absolute value inequality. So what this means, we did a lot of number line talks here. This quantity is going to be within 10 units from 0, or once we simplify, that would be an easier case to make. This quantity is within 6 units of 0. So that means it's inside of positive 6 and negative 6. So remember, we learned how to do it like this. Less than or equal to, less than or equal to. And then this was a compound inequality, but it was nice because you could just solve it all at once. So I have negative 8 is less than or equal to x is less than or equal to 4. And you can try those answers and see if they work, right? Negative 8 plus 2 That's negative 6. The absolute value is going to be 6 plus 4 is 10. 10 is less than or equal to 10. Right, same thing's going to work with 4, right? 4 plus 2 is 6. 6 plus 4 is 10. 10 is less than or equal to 10. Any number in between there should work. That's why it's written as it is. So let's try an easy one like 0. 0 plus 2 is 2. 2 plus 4 is 6. 6 is less than or equal to 10. Booyah, as Stuart Scott used to say. Okay, moving on. So we do have an absolute value graph to complete. Alright, let's see if we can make that relatively easy. Remember, I think as a class, you did okay on this. And then the minus 3. So inside the absolute value shifts things horizontally. The outer number added or subtracted is a vertical shift, and this number is simply the slope. So from there we're going to think, okay, it's going to move left 1 and down 3. Left 1 and down 3 from where? From the origin. So left 1 and down 3. All right, and we've got this basic shape of a V because it's a positive 2. Remember all these things? Right, so up and over. That's going to be 0. What am I going to get when I plug in 0? Negative 1. We've got symmetry for these. Kind of like a lot of the same ideas for parabolas. We're going to use that here. So negative 2, negative 1 should be on there. Due to that symmetry, check to see if that it is. Negative 2 plus 1 is negative 1. The absolute value of which is 1 times 2 is 2 minus 3. Yup. Okay. That wasn't so bad. And then in B, we're given a quadratic times a linear, or if you multiply that out, you're going to get a nice standard form function. I'm going to take the liberty of go ahead and factoring that, because x squared minus 4 is the difference of squares. And from there we can say, oh, well that's easy. I know the 3 points are negative 2, positive 2, and positive 5. Right? That's where those come from. And I'm just going to connect the dots in a topsy-turvy-curvy sort of thing, right? Well, the end behavior was kind of important, but since this was a positive, right, there's no negative leading coefficient. We're going to go to the farthest right, we're going to go up. All right? The other thing to do would be to check that y-intercept by multiplying all the constants. Negative 4 times negative 5 is going to be positive 20. So positive, right? Great. Okay. Letter C. Letter C. What on earth is letter C? I'm going to have to take a step back and really look at that for a second. Okay, not really. I was just kidding. Letter C is a circle, folks. Circles were learned in math 2. So what I can do is kind of give you a quick refresher. Circles were based on the distance from the center. Circles are defined as a collection of all the points that are the same distance from a common point, that common point being the center. Maybe you remember this, x minus h squared